Welcome to Sound Policy, a new podcast from FM. On this show, you'll hear from engineers, researchers, and insurance professionals who are helping shape the future of protection and progress in business. I'm Brian Amaral, your host for this episode. I spent a decade and a half as a journalist, asking questions and seeking facts. Now I work for FM, a leader in commercial property insurance, and on today's show, we'll be asking questions and seeking facts about fire risks. The world faces plenty of challenges right now. New geopolitical tensions, climate change, technology that will unlock innovation, but also new threats. But what about the oldest risk? For FM, fire is still the number one driver of losses. Why is that? What new technologies are heightening the risk, and what new technologies are helping address it? To discuss that today, we're talking with Lou Gritzo, Chief Science Officer at FM. Lou, welcome to the podcast. Thanks for being on.
My pleasure.
First, can you introduce yourself? How long have you been at FM? What do you do at FM?
I'm Lou Gritzo. I'm the Chief Science Officer at FM. I'm responsible for our technical strategy for managing emerging and underserved risks. And I've been at FM for almost 20 years now.
So we're talking about fire today. What's your background in fire?
So I started doing research in fire science after my graduate degree. I went to work for a national laboratory, and at that time, there were a lot of weapon systems being dismantled, and they were being transported, and there was concerns about what would happen if they got in a fire. So that kind of started my trajectory in fire science, and of course, it's still incredibly important today.
Fire is the number one loss driver for FM right now. Do you think a lot of people know that? Is that something that might surprise people?
You know, I think that top of mind today is largely climate risk. That's what companies are thinking about. When we look at emerging risk studies, that tends to pop to the top. And that's because it's changing. And things that are changing are the ones that seem to get attention, and justifiably so. And as important as climate risk is, fire continues to be that problem that can't quite be solved completely and causes maybe some under-the-radar kinds of losses for companies because maybe we've just grown a little bit used to it to a certain extent.
Can't be solved. What's behind that? Why can't it be solved? What are some of the challenges there?
We technically know how to put out fires. Fire sprinklers have been around for a long time. The challenge is that when those fires start, even with current technology, they still do a fair amount of damage. And sometimes that technology is not accepted. Maybe those protection systems aren't installed or not maintained correctly. And so we just continue to see these fires occur, not only some small ones that, are manageable, but some really big fires that rage out of control. Batteries really are kind of top of mind right now. And in addition to climate, there's been a lot of cases where batteries have been attributable as the source of a fire, because they go into thermal runaway. So I think that's kind of brought fire a little bit to the top of the radar screen now from being fairly low. But when we look at just the overall numbers and the gross loss for businesses, it's still fire.
FM did a survey recently on natural hazards, and one of the questions we asked corporate insurance buyers and brokers about the risks being most regularly discussed at the board level, fire and explosion came in 7th of the risks that we asked about after reputational risk and before disease and pandemic. To put it bluntly, do they have it wrong? Should it be higher on that list?
I'm not sure it should be higher, but it certainly shouldn't be off the list. Boards justifiably so are thinking about what's the issue of the day and what are the things that companies need to be thinking about for tomorrow. I think what might have happened here is that we've just gotten a little bit to the point where there's too much acceptance of it. Fires still are fairly rare, and boards are focused on, okay, what are the things that we as a company need to be thinking about, not necessarily the things that have plagued us in the past or that we've always dealt with. They're more forward thinking, which is good to a certain extent. But the challenge is we miss those opportunities for companies to tackle the issues that they've always dealt with, but might not have to deal with them any longer if they would take a different approach.
It's interesting. FM's corporate history going back to 1835 is the Manufacturers Mutual Fire Insurance Company of Rhode Island back in 1835 when fire was the big risk for mill buildings. 2025, the statistics show that it's still, even beyond the natural hazards, the boiler and machinery, the escaped liquids, still continues to outpace those other ones. What needs to happen to reduce the incidence of fire and how much damage they can cause?
Two things need to happen. First is that technology needs to be used to improve fire protection systems. It's been 150 years since the first industrial fire protection system was installed in a piano factory in New Haven, Connecticut. 1874.
1874.
In 1874, a gentleman, Parmalee, owned a piano manufacturer in New Haven, and he invented, and actually patented a couple years prior to that, the first automatic fire sprinkler. And it works very similar to the fire sprinklers of today. It has something that heats up, and when it heats up, it opens up a hole in the device, and water can come out. It wasn't really adopted very quickly. So the first fire sprinkler that went in an industrial building was not something that really just took off and was widely accepted. And reportedly, the reasons for that is it was maybe a little expensive and it was complex and there wasn't a whole lot of comfort around the reliability. So fast forward to today. In 2017, FM published a public report on what we call the smart fire sprinkler system, where you use an array of sensors, multi-parameter sensors to avoid false alarms, an algorithm behind those sensors that finds fires when they're small, and then a control system to release a small amount of water to extinguish fires before they grow, rather than wait for them to activate a sprinkler on the ceiling or somewhere else. The challenges with adoption? Same things Henry Parmalee faced in 1874. It's expensive. It's complex. I'm concerned about the reliability. So even though we did a reliability study a few years later, showed that with correct maintenance and operations, it could be just as reliable as today's fire sprinkler system, it still hasn't taken off. We have a couple of partner companies we're working with here at FM, but progress is slow. So first thing that has to happen to move the ball forward is technology, the use of technology. The second piece is monitoring the technology that comes out in industrial facilities and being able to get on top of that faster. And here's where we see the move towards more electric equipment, mass electrification, if you will. We're moving away from fossil fuels to more electrical systems, the prevalence of batteries in places that we've never seen them before, the demographic shifts of a lot of experienced people retiring, automated systems that take people out of buildings so the people can oftentimes be the first ones to see a fire when it's small. Those are all things that challenge us to come up with new protection solutions faster and deal with this changing landscape.
You were mentioning batteries and electrification. We mentioned that fires are still the number one loss driver for FM. What sorts of fires? What is the big driver of those fires?
The biggest ignition source in industrial fires have to do with the electrical system. It's switchgear, it's a box, it's a short somewhere, and that small electrical spark heats something up and causes a fire to grow. So as we look to increasingly complex automated systems, electrical systems to replace fossil fuel heating or industrial equipment, there's got to be a conscious decision to make sure that, first of all, those fires don't start. They're good quality systems. But maybe even more importantly, we use monitoring technology to see when that system is operating off normal, when maybe there's a fire that's incipient, and start to tackle them early rather than wait for them to get hot and activate a ceiling sprinkler.
Speaking of technology, off-gas detection, water mist systems, can you talk about those technologies, how they're emerging and might help combat this issue?
Well, batteries have really placed fire safety at the forefront for a number of applications. Certainly, renewable systems use battery energy storage to keep some of that energy to when it needs to be used. Maybe it's generated at one time and used at a later time. And thermal runaway, or when those batteries go into an off-normal condition and start to heat up, is really the big challenge to face relative to fire hazards in batteries. When batteries start to go into thermal runaway, as they heat up, of course, they get warmer, but that temperature produces some gases, some light gases from the battery itself. Those gases can be sensed. And using modern sensor technology, finding those gases as a signal of incipient thermal runaway and being able to shut off that system is an effective use of addressing a fire before it starts, preventing a fire from becoming significant. The big challenge with batteries is that they have a lot of energy. That's what batteries are good for. So other than trying to attack the battery fire before it starts, the only other solution is really just quench it and drop the temperature down as much as possible, which is why batteries are such a challenge.
We are recording this at our headquarters in Johnston, Rhode Island. We're a few miles away from the FM research campus in West Gloucester, Rhode Island. What sort of work goes on at the fire lab there?
The fire technology lab at the FM research campus is really focused on grounding the science that FM brings to fire protection in reality. It includes small, intermediate, and very large, up to the size of a small house, fire testing capabilities that allow FM to understand new hazards and, probably most importantly, develop new loss prevention solutions and make sure that they work. So grounding those kinds of solutions in reality and perhaps in some cases, even more importantly, being able to show a real scale fire to a company that has that challenge and show how those solutions can be implemented to address that hazard is a core part of what the FM Research Campus here in Rhode Island does.
What's the most unusual thing that has been set on fire at the research campus while you were there? What's your most memorable test?
Visitors to the FM Research Campus ask that question about what is the strangest thing you've ever tested. And it ranges for all the things that you can imagine in commercial industrial properties. Some work for distilled spirits. This is the project that every researcher wanted to work on until they found out that there were no drinkable distilled spirits involved. And a number of years ago, after one of the major storms, we had some surplus yachts. So we had the opportunity to do some fire testing on luxury yachts and find a great solution to protect those while they're being manufactured. So really anything that is relevant for industry can be tested there. The challenge at the FM Research Campus is being able to develop the science behind it to minimize the number of full-scale tests we do. And so for that, in 2008, we started a significant computational fire modeling effort. FM took a very unique approach on this, a very strategic long-term approach, which is consistent with our mutual ownership of making that model development open source. Open to government, our clients, academia to contribute to the development of that tool. And in the time that has passed, it's become a viable solution for doing calculations of fire spread and fire protection that give us insight into fire phenomena that allow us to test smarter and do fewer tests, which allows us to solve more problems faster.
When you're bringing a client around the research campus and you're doing a large-scale fire test, what are they telling you? What's going through their minds as they're seeing the large warehouse tests, for example, go up in flames?
Last year, FM brought 3,000 visitors through our research campus to see what we do. The number one thing that we hear when they see a full-scale fire test is how fast that fire grew, how much heat was produced from it quickly. In a few moments, something that looks like just an ordinary storage of boxes in a warehouse becomes a wall of flame. And it really drives home the message that most of the time we're fortunate enough to where we're not experiencing fires. But when fires occur, they either fizzle out or they take off. There's very little in between.
For people who have been to the research campus, you may know that you're watching the fire from behind a glass partition, obviously, and you're seeing this big fire, but you can really feel the heat coming off that fire even from the test, right? I mean, walk us through what are the senses that you're seeing and feeling and smelling even when you're at the research campus watching a large-scale fire test?
Large-scale fire testing at the FM Research Campus is really focused on making sure that there's a safe experiment that is realistic, that provides us a solution or illustrates a solution to a client. Clients are in a visitor's gallery that is protected by heavy glass. They're in an air-conditioned space, so they don't smell the fire, which is a good thing. But you certainly can feel the heat of the fire through the glass, even being on the order of 40, 50 feet away from the flame zone. And that's just simply the scale of industrial fires. They produce an incredible amount of heat, even at that distance. And so the opportunity at the research campus is to make sure that reality is played out in a way that is, first of all, safe for our employees and protects our property, which is our job, but also provides solutions and an experience for clients that they understand those solutions. Nothing changes a company risk manager or even a CFO's mind about whether or not they should invest in some fire protection solution faster than seeing the consequences of an unprotected large-scale fire.
What about fire risk keeps you up at night?
The changing hazard of fire risk is the big problem. Those are the things that I worry about missing. We know that businesses now have batteries where they didn't. We're carrying these little batteries, which are potential ignition sources, around with us all the time. Automated systems, more tightly packed plastics, combustible materials in industrial facilities. And on top of that, the future of water scarcity. Water's still the best way to put out a fire. And in many places, that water is not available. If you pile on top of that the changing climate, increased temperature, and the drive to be more sustainable through electrification, and electricity is the number one source of ignition for fires, there's a lot of factors that add up to produce a very rapidly changing hazard. And it becomes a foot race for the hazard assessment and the solutions to be in place in time before the fire hazard starts to outgrow or outscale the solution space. And that's the challenge, is seeing those challenges as they evolve, understanding that when they go to the extreme case where a fire is going to be out of control, where we can break that chain and do that research in time for the solutions to be in a client facility is the grand challenge that we face.
So when people think about insurance and fires, we've been talking a lot about electrical fires, warehouse fires, but it seems like a lot of people might think about wildfires as well. Obviously been in the news lately. What role is climate change playing in the wildfires that we're seeing? And why is this a really high profile peril right now?
Certainly, a warmer climate has produced the potential for more severe wildfires, but it's not the climate alone. The policies in the United States and many places around the world has been to put out any kind of wildfire as quickly as possible. And that's resulted in a significant accumulation of fuels, dead wood, that's just ready to burn in the forests. So on top of that, we have a warming climate. And if there's no moisture to be captured in that warm air, then it results in an extended period of drought. And moisture content of the forest materials is the number one factor that causes fire intensity and to some extent fire spread, absent wind and other factors. So the wildfire problem for businesses really faced, I would say, a cliff in 2017. That's when we saw major California fires. 2018 had the Camp Fire, which basically decimated the town of Paradise, California. So at that point in time, fires went from fires in the forest that maybe affected some towns, but mostly mountain towns, to fires that would involve urban and suburban areas, and spreading very quickly due to a lot of embers, made worse by the wind. And all these things stack up to produce incredibly fast-moving fires, fires that move much faster than the wind blows. And that takes communities and businesses by surprise. And once structures start to get involved in fires, the heat release from a structure is about 10 times the heat release from any forested materials. So that makes it very difficult to extinguish those fires. On top of the challenges that we have with development and the accumulation of forest fuels, the buildup of economic value in areas that are fairly forested, and we all like trees, has resulted in a lot more value at risk. So all these things together have made wildfire a risk that is more significant than it's ever been in the past, more difficult to deal with because they're big. In some cases, they're year-round. There's no longer a fire season. The California fires of 2025 happen in January, not when you would think is fire season. So all these things stack up to make wildfire a challenge.
What are some resilience strategies for wildfire?
Probably the single best thing to prevent a structure from being engaged in a wildfire is non-combustible construction. Making sure that the building envelope doesn't have combustible components, especially those on the exterior of the building. That prevents any embers or any kind of flames that are adjacent to the structure from catching the structure on fire.
Yeah, can you give examples of what some of those materials are?
Good examples of non-combustible materials in the exterior of a building are having fire-rated shingles, a fire-rated roof. Oftentimes embers will land on those roofs. Of course, you have to keep them clean, keep all the pine needles or any kind of leaves and things off of them as well. Siding that is not combustible, different composite materials or concretious kind of siding materials. There are a lot of options for non-combustible construction other than just a basic boring cinder block. Brick and stucco, if they don't have anything flammable behind them, are good options as well.
Does FM Approvals do any of that testing to certify against wildfires?
For commercial buildings, FM-approved wall panels are a great way to ensure that they're non-combustible construction on the outside, and they're also tested and certified for wind relative to the wind zone of the building.
Have we gotten to the point where there are certain places where people shouldn't be building because of the risk of wildfire?
I wouldn't go so far as to say there are some places where there should be no construction due to the wildfire hazard. The wildfire hazard can be managed with good land use planning, and that land use planning includes open spaces, areas for fire protection, areas with green space that will ensure that embers don't, get adjacent to a building. And the correct construction type, having plantings around the building that are low combustibility Certainly plants with high salt content, high moisture content, very few oils are good options. So there are land use and design options for building in what otherwise would be a wildfire-prone area. And also managing the forest materials in those areas becomes very important. Adjacent areas often benefit significantly from what's called forest thinning, which is going in and trimming out some of that dead wood that's accumulated over the years, especially if the policy in that region has been to put fires out and not let them burn naturally. So the pieces of that puzzle can come together to result in a fairly resilient or robust protection against wildfires. Of course, and then on top of that, there's that great emergency response plan you always need to have in case something happens.
For the other sorts of fires that we're talking about, the electrical fires, the sorts of that are the main loss drivers, what are some resilient strategies for those?
Fires inside a building include a lot of different options for ensuring, first of all, that they don't start. Second, if they start, they don't spread. And third, if they start and they spread, you put them out as quickly as possible. So the exact strategy depends on what you're doing in the building. Is it a manufacturing line that has certain oils and lubricants, ignitable liquids as we call them? Whether it's a frozen food warehouse where there's, combustible items in boxes, but also, a lot of insulation materials that are involved in the construction. So really understanding the hazards, the construction hazards, the occupancy hazards, and then identifying the right prevention protection options are critical for businesses.
What are some of the technological advancements that are happening right now that excite you that might help address this issue?
Technology presents the opportunity to really manage the fire problem effectively. And it starts with sensors that can identify when a fire is about to start, making those sensors connected to systems that allow the appropriate response given the operations. For example, a switch panel that's starting to overheat, you're not going to just turn the power off all of a sudden. You have to have some operations to say what is appropriate, who's going to do what, and what's my preventative measures there. On top of that, the ability to find fires through different sensing technology, video sensing technology, heat, temperature, and then be able to get the right kind of protection solution. Water is still the best solution for putting out fires, but it's not always appropriate. Get the right solution for that fire when the fire's small. So all fires start small. Explosions, not so much, but all fires start small. So the idea is to sense it, try and keep it from starting, and then put it out when it's small. And there's all kinds of sensing and extinguishment technologies that are really developed from a technical perspective. It's not the technology that's the barrier. It's the integration, the commercialization, and the innovation in getting those to overcome the 150-year-old problem of cost, complexity, and reliability.
Back at that piano factory.
Back to the piano factory. History repeats itself.
Speaking of technology, you're one of the inventors on a patent, US 9805588B2, wireless fire protection, valve inspections, and monitoring systems. What's the story there?
The story behind that patent is when we were reviewing losses within the research organization to see opportunities for us to ensure that our research was going to reduce those losses. One of the things that really stuck out was this notion of improperly closed valves, which means that there's a fire protection solution there and it's installed, it should work, but somebody somehow closed a valve and it's not going to allow the water to get to the fire. And that valve could have been closed because there's a maintenance, they needed to do something within that sprinkler system or within the area. It could be that somebody closed it by mistake, or it could be that the valve is just flat out broken. So I was thinking about that one day and I was pulling out my badge to get into the building and I tapped it against the RFID card reader. And I thought, so I have good technology that this door knows it's me and knows I need in. Can we apply that to a fire protection valve to where we know it's open and the right people know it's open and the company doesn't have to send people around to go and check all those valves? They can use the same technology. So that's basically how that patent came about. A solution to use technology to solve a problem that would reduce fire losses by greater than a factor of 10. So if those valves are closed, the average loss is on the order of $3.5 million. If those valves are open and the fire protection system works, then the losses are less than $300,000. So what that patent did was allow companies then to come in, because we non-exclusively royalty-free license our intellectual property here at FM to try and encourage commercialization of that property, but allow a company to come in and put a product on the market and allow clients to use it to know their valves are open without having to send one of their people chasing down valves all over the facility, which in some cases can include hundreds of valves for a large industrial complex.
Is it in use now?
Absolutely. There are FM-approved wireless monitoring systems for those valves on the market right now.
But it is a non-exclusive, royalty-free patent, so anybody can use this patent and take it and put it in their system?
FM's goal through our research is to make solutions available to clients as quickly and cost-effectively as possible. So the approach of non-exclusively royalty-free licensing our technology is to try and encourage that adoption. FM Approvals Group will test and certify those products when they make it onto the market, but our goal is to try and get as many tools in the toolbox, if you will, for solutions to the age-old fire problem.
Lou, thanks for being on the show.
My pleasure.
This has been Sound Policy. Stay tuned for more interviews to help protect your purpose. I'm Brian Amaral. Talk to you next time. Copyright 2025, Factory Mutual Insurance Company, all rights reserved. This podcast is for informational purposes only and aims to highlight potential hazards or conditions to help reduce property loss. FM makes no express or implied warranties and assumes no liability for the use of any information or products mentioned.